Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 16 physics series where we are discussing each and every chapter concept wise. So today we are going to discuss alternating current, and in that chapter we are mainly going to discuss about AC through resistors, capacitors and inductors. Okay, now yesterday was your KPL 4 in physics. Tell me, have you attempted that series? If you have not yet attempted and wondering how you can attempt KPL series, then you have to join our WhatsApp group where we are posting the question paper every Sunday. So every Sunday the test is happening. You can download the question paper, and in the night I will be back with the solution. So yesterday I have already given the solution for KPL, and today we are going to start a new chapter, alternating current. So if you have attempted last week's KPL, please mention in the comment below how much you scored in yesterday's KPL session. So now let's start with a new chapter, alternating current. This is a very important chapter. For each and every portion of this chapter is important, even including the beginning part, that is resistors, inductor, capacitors. These are also very important concept wise, and if you are preparing for your PU2 exam, this is going to be very helpful for you, as we are distributing this chapter into different parts. First we are going to discuss about AC and DC, then we are going to talk about AC applied to resistors, then we will briefly talk about phasors, then AC applied to inductors, and last we are going to talk about AC applied to capacitors. So up to this part we will be covering in this part, and hopefully I will complete the chapter in our next video. There we will be talking about LCR circuit, LR circuit, LC circuit, etc., and hopefully we will be able to complete that in our next part. If not, then maybe we will need one more part for this chapter. So mostly by 3 parts, maximum 3 parts, this chapter will be completed. Okay, so but this is a very important chapter. A lot of question comes from this chapter every year. 4 questions comes from this chapter, so you cannot ignore this chapter. Very important concept. But before we start, let us discuss about DC and AC. It is very common term we use: DC current, AC current, AC voltage, DC voltage. So what is DC means? DC means current that does not change its direction. It is only one directional. So for example, if you consider an DC voltage, so this is basically, it is not changing, it is constant over time. So if you consider this time and this is the voltage, it always remains positive. Okay, its sign does not change. Okay, that is the meaning of DC. Okay, now one more thing. Now what is AC? AC is what? If something is changing with time, okay, the direction is changing, the polarity is changing, then we call it AC current. Okay, so for example, if I draw the same diagram, okay, suppose till 1 second it is +1, and after 1 second it is -1, and like so, then we call it a AC. Okay, so then we call it an AC, right? Like this. Even this is an AC. Even this is an AC. Okay, but commonly, most commonly, AC means, we understand this. This is a sine curve or sinusoidal curve, whatever you say. Okay, this is the basic meaning of AC. So after in some time it is positive, some time it is negative. So this is plus, this is minus. We know that y-axis up is positive, below is negative. So for some time it is positive, for some time it is negative. So that's why this is called AC. Now there is a very common term that we use: AC current or AC voltage. Basically AC itself means alternating current. Okay, so AC current means alternating current, and AC voltage means alternating current voltage. even though it is redundant, it is very commonly used, and even in your books, in every books basically they mention AC current, AC voltage, but you should know that actually it is like AC is a short form of alternating current, and in our day-to-day life, even though we mention AC current, AC itself is current. So if you become little bit careful from next time onwards, if you are talking about AC current, say only AC, sufficient. AC voltage is alternating voltage. We do not mention something called AC alternating voltage, but AC voltage is fine. But if you are saying AC current, from next time onwards, if you are talking to some friends or your parents or anyone, tell them AC. Okay, AC does not mean air conditioner. AC means alternating current. Okay, this is one confusion students have, so I am here to clear all the confusion. Now AC varies as sine function. So this is a sine function. Okay, this is called sine function, and generally AC voltage is represented by V equals to Vm sine omega t. Okay, this is what? This is like your simple harmonic motion. If you remember simple harmonic motion, where we used to say y is equal to amplitude sine omega t. Here it is same, y is varying, so here v, this axis is v axis, this is time axis, right? So this is very similar to that of simple harmonic motion. In fact, this equation is of a simple harmonic motion, and here this amplitude term is replaced by a term called Vm. Here Vm is the maximum value of the voltage. So maximum positive value or maximum negative value, this is Vm. This is Vm. This is in the negative side, this is in the positive side. Both are Vms magnitude wise. Okay, so this is the magnitude of the maximum possible value, right? And omega is the angular frequency. That means how much time it takes to complete one rotation. If we will go to the phasor diagram, then there I will explain omega term once more, but it is basically angular frequency. Okay, you can write omega in terms of normal frequency, 2 pi nu, right? So you can write it in terms of normal frequency as well, right? Now let's move on. As I said, V is equal to Vm sine omega t is the representation of the function. Now let's move on. Now let us consider voltage applied, AC voltage applied to a resistor. Now in case of normal DC voltage, if you remember, we have used this symbol for a battery or a cell. Okay, so this is a source of DC, right? Now in case of AC, we do not use this symbol, we cannot use this symbol. So what symbol we use? We use this kind of symbol. This is the symbol for AC. This is an AC source. Okay, so this is a symbol for AC source. Okay, and resistance symbol remains same. Okay, resistance symbol remains same whether you apply DC, whether you apply AC, does not matter. Resistance symbol will remain same, and the Ohm's law will still be valid. Ohm's law will still be applicable, but in a different way. We will see that in a while. So from Ohm's law we can write that V equals to IR. Here this current I is not normal current. This current is basically AC current, right? This current is AC current, and we know that V is basically Vm sine omega t. You have written that in our previous part. So from this we can find the current. Okay, current will be Vm sine omega t divided by R, right? Now from there we can write this as Vm by R sine omega t, right? Now this term Vm by R, we can write this term as Im. Now what is Im? So Vm was the maximum value of the voltage, AC voltage. Maximum value of the AC voltage divided by resistance is the maximum value of the current, right? So basically we can say that Im is Vm by R. So the Ohm's law is applicable for the maximum current as well, right? So from here we can write this. Now power, Similarly, like Ohm's law, we also have to find the power, how much power it is using. So power used by a resistor is given by I square R. Okay, now let us put the value of I square. I is sine omega t, right? I am sine omega t, so I am square and sine square omega t. So this is the value of the power. Now average power, which is more important when we are using AC current, more than power, instantaneous power, average power is important, because this is instantaneous power, right? So at some value of sine theta will be 0, so sine omega t will be 0 at some value. So at that point sine omega t will be 0, at some point sine omega t will be plus 1, so that point it will be maximum. So you will get a fluctuating power, right? So for some value you will get maximum power, some value you will get 0 power. So this is not useful for us. So for an example, when you are saying that you are seeing one machine, one fridge, for example, fridge or AC, they have mentioned that average power consumed. So that average power is basically the average of the power of all the components, right? So the power average is very important when we are talking about AC current. So now the average power is basically average of all the terms. Now I square R is a constant term, right? I am square R is a constant term, so this has a fixed value. Its average will be same. If it is a constant, its average is same as that. So if I say that what is the average of 10, average of 10 is 10 itself, okay? But if it is changing between say 10 to 0, then what is the average value? Then we will do maximum value plus minimum value divided by 2, that is the average value is 5. But if it is not changing, if it is constant, then the average value will remain constant. Similarly here I square R is not changing with time, that means its average value will remain constant. But this term sine square omega t, it is changing with time, okay? So it is changing with time, so it will have an average value. Now you should remember that average value of sine square theta, any average value of sine square theta or even cos square theta, its average value when theta is changing, okay, it's half. Average value is half. Similarly, when you are talking about average value of normal sine theta, it is or even cos theta. So we know that sine theta varies from plus 1 to minus 1, right? So its average value will be plus 1 minus 1 divided by 2, that is 0. Okay, so average value of sine theta and cos theta is 0. Average value of sine square theta and cos square theta is half. It is briefly discussed in your textbook. If you want, you can check that, but that is not part of our discussion today, so I am not going into that detail. But I will write the power here as P is equal to half I m square R. This is the power dissipated by a resistive circuit in AC. Normally in case of DC it was I square R, right? Normally in DC it is I square R, but in case of AC it's already half. So even if you are using AC current, it's actually consuming less power than it should have in DC current. So that's why AC is one of the most popular things. In the beginning of the current war, if you know, there was a current war between different factions, okay? Some Nikola Tesla pioneered AC, whereas there were some people who were actually in favor of DC, but later on it was realized that AC is easy to transmit without losing much power, without generating too much heat. That's why AC was adopted, okay? Now here the average power of sine square omega t is half. Not only sine square omega t, cos square theta, sine square theta, whatever, whenever we are talking about time variance of sine square, cos square, they are half. Whenever we are talking about time variance of sine and cos, they are 0. Okay, now let's move on. One problem. A 100-watt bulb is connected to an AC source of 220 volt 50 Hz. Then the current flowing through the bulb is. Very simple question. This is a question where people, you will be confused what to do. They have given a lot of values. Okay, a bulb, the watt power consumed by the bulb is given by 100 watt. This is the average power. Remember that this is average power, and it is connected to an AC source of 220 volt. So P is equal to what? VI. Okay, V is given 220 volts, and you have to find I. Okay, don't worry, the same equation, same formula is valid for AC as well. Whatever you have used, vitamin, I told you, remember the term vitamin. Okay, that will help, that will be helpful for you. So 5 by 11. So 5 by 11 ampere is the current. So correct answer is option A. Okay, same formula is applicable. Don't worry, even if they have mentioned simple like these problems, this is a simple KCET problem from your previous year question papers. Okay, 4-5 years back this question came, but still very relevant question and very confusing. You may get confused about how to find the power or current. Formula is same. Okay, power is given, V is given, you are trying to find I. Only thing they have given you confusing to you is that the hertz, that is frequency. So don't worry about it. Okay, just simply apply the formula that you know, you answer it. Okay, now let's move on. Voltage applied to resistor, to express the power in the same form as DC power, P is equal to I square R, a special value of current is defined and is used. It is called root mean square or RMS value, effective current, and is denoted by IRMS or I. So this is the basically effective current whenever you are saying power AC. So previous problem where we are calculating it, it was actually RMS current, and in fact V was also given in RMS value. We will discuss that in a while, but even if you don't know about RMS, you can still use your DC knowledge to solve that problem, right? That was my goal. That's why I given that problem before we are coming to RMS, concept of RMS. So RMS current is basically given by Im divided by root 2. Okay, and VRMS is defined by Vm by root 2. Now why this is done? So you will see that we will see that we know that what was power in case of average power was half Im Vm, right? Or Im square R, or we can write this as Im Vm, or we can write this as Im by root 2 times Vm by root 2. Okay, or we can write this as IRMS VRMS. Okay, so basically we can use this formula. P is equal to vitamin. P is equal to vitamin is applicable, not vitamin without T. Okay, so this is still applicable in this case as well. Only thing you need to remember is in this case, instead of normal, it will be IRMS VRMS. Okay, and the power rating that is mentioned in a power source, so that is it is a 220 volt AC. This is a 440 volt AC. Okay, this is a say 1000 AC, 1000 kilowatt AC, 1000 kilovolt AC. So basically those are nothing but RMS values. Whenever we say this is a 220 volt AC, that means the RMS value of the voltage that is coming through that circuit, coming through that port, is basically 220 volt. Okay, now you should remember that 220 volt AC is more dangerous than 220 volt DC. That is a very common question in PU board. So mention in the comment, why do you think the value of 220 volt AC is more dangerous than that of 220 volt AC? If you are watching up to this point, please mention that in the comment, why 220 volt AC is more dangerous than 220 volt DC. Okay, I am not going to discuss, that is not in part of the KCET anyway, but it is a good question for PU. The frequency of an alternating current is 50 Hz. Okay, what is the minimum time taken by current to reach its peak value from RMS value? So the frequency of an alternating current is given, frequency is given, nu is given 50 Hz. Okay, and they have asked you what is the minimum time taken by the current to reach its peak value from RMS value. We know that V is equal to V max times sin omega t. Okay, and omega is basically 2 pi nu. Some books, some people, some students, they use F as frequency instead of nu, but frequency is frequency. You will write nu in terms when you are studying with dual nature of light, okay, or light theory, but here you are using F, but the same thing, that frequency and this frequency are same thing. Okay, frequency means frequency, so I am using the common symbol for frequency, which is nu. Okay, in your previous classes maybe you have used the symbol F, but that is fine. I am throughout my lecture I am going to use the symbol nu. If you have any doubt, any confusion, you can mention that in the comment below. Right, now frequency is mentioned is 50 Hertz. So that means you have, what you have to do, 2 pi times 50. So omega is 100 pi. Omega given here is 100 pi, and V is given. What is the value of V? V is given here is VRMS. So VRMS is, okay, let me use in a detailed answer only. I will not use any shortcut so that you don't get confused. So this is basically VRMS. Initial value is VRMS, right? The minimum time required to current to reach its peak value from RMS value. So initial value is VRMS, okay, and you are trying to reach its peak value, right? Now what is VRMS? We already know VRMS is nothing but Vm by root 2, right, and equals to Vm sin omega t. Okay, so sin omega t is nothing but 1 by root 2. Now when the value of sin omega t is 1 by root 2, the value of sin omega t is 1 by root 2 when it is 45 degrees, right? So this is sin pi by 4, right? So it is pi by 4. Now so comparing, we can write this as omega t is pi by 4. Omega t is pi by 4. Now use the value of omega, 100 pi. So 100 pi is equal to 100 pi times t is equal to pi by 4, or t is equal to pi cancels, 1 by 400. Okay. So 1 by 400 can be written as 0.25 times 10 to the power of minus 2. Okay. Now if you see the correct option, if you are writing in terms of option, it will be 2.5 times 10 to the power of minus 3 seconds. So the correct answer is option D. Very simple question. If you answer it properly, you will get this answer, but you have to be careful. Okay. So you can reduce the calculation time if you are familiar with this formula, but I have used all the method, all the steps without skipping any steps, because this is something new for you. You have never used this kind of equations, never used this kind of formulas, so you might find this little difficult, but this is very common type of questions. Now let's look into the last last week I think I did that on a Friday. So Friday's homework problems. 3 identical coils A, B and C are carrying currents are placed coaxially with their planes parallel to one another. A and C carry currents as shown in the figure. So A and C are carrying current like this. This is carrying current like this. Okay, as shown in the figure. B is kept fixed while A and C both are moved towards B with the same speed initially. Okay, B is equally separated from A and C. The direction of induced current in the coil B is. So now if you see, what is the magnetic field on this? What is the magnetic field of this coil? This coil is actually, this coil is like this. Okay, they are not flat. Okay, they are not flat. So what is the direction of magnetic field induced in this? So magnetic field is going this way, so it is along this direction. So for this coil A, the magnetic field is in this direction. And what is the magnetic field due to this? So magnetic field due to this is in this direction. So they are opposing each other. So they are opposing each other means they will cancel each other. They cancel each other means there is no net magnetic flux changing through the center coil. So the magnetic flux induced in this case will be 0. So EMF induced in this case will be 0. Now let's look into the next problem. A current carrying coil, it changes from 2 ampere to 5 ampere in 3 seconds. I think I have solved a similar problem. The magnitude of EMF induced in the coil is 1 volts. The value of the self inductance of the coil is. So now we know that induced EMF is L di dt, right? So induced EMF is 1 volt, L we don't know, di is 5 minus 2 and dt is 0.3 seconds. So it is L times 3 divided by 0.3. So 1 equals to L times 10. This is 3 divided by 0.3 is 10. So L is 0.1 Henry. L is 0.1 Henry, but they have mentioned the answer in millihenry, so it will be 100 millihenry. Okay, simple as that. So correct answer is option A. Now let's look back to our topic of the day, phasors. Now let us talk about phasors. What is a phasor? In order to show the phase relationship between voltage and current in an AC circuit, okay, we use the notion of phasors. Notion means it's a concept, okay. It does not really exist in nature, but it is very useful, very handy to understand, to simplify the mathematics, okay. Sometimes we will say it is leading by a phase of pi by 2, it is lagging by a phase of pi by 2. So and phasors are actually a diagrammatical representation of that, okay. So even though they are ahead of phase, it is between the phase, but sometimes phasor is very important. For example, let me explain the term about phasor. Suppose we have a train, okay, we have a train, there is one bogie, okay, there is another bogie, and there is an engine. There is an engine. Now if you see, the engine will always remain ahead, right? If you are sitting here, suppose you are sitting here, what you will say, that engine is say 500 meters ahead of me, right? And if someone is sitting here, he will say engine is 250 meters ahead of me, okay. And suppose this person is A, this person is B, and person A will say person B is 250 meters ahead of me, okay. So for this person, he is leading, he is ahead, okay, but any point of time their relative distance is not changing. But if you see from perspective of this point, the train is moving in this direction, then you will say that B is ahead, A is falling behind, okay. Similarly, the engine E is always ahead. So what is in terms of phasor diagrams, we just represent, we just say who is ahead, who is falling behind, who is behind that, okay. Sometimes this distance can change with time, okay. They are saying that with the phase distance, phase is changing with time, changing phase. Sometimes the phase relation is fixed, but one is ahead, another one is behind, and they cannot cross each other, okay. So that is very important. Now let's look into one phasor diagram of this current versus voltage thing, okay. I am erasing that. This is just for concept. You will only get this when you are watching this video. If you are downloading the PDF from our website, you will not get this kind of detailed information, right? So that's why I say don't miss our lectures, watch the lecture completely, okay. And one more thing, the lecture notes will be available after the class is over. You can download the lecture notes from the link given in the comment, okay. Now, so for example, in the case of a resistor, we saw that what was voltage? Voltage was V is equal to Vm sin omega t, right? And we calculated current as Im sin omega t. Now the magnitude of this amplitude are different, okay. In fact, Im, we have found Im is basically Vm by R, right? That also you have calculated. So Im and Vm are values are not same. Im and Vm's values are not same, but they are sharing the same sine function, that is sin omega t, okay. They are sharing the same function sin omega t, so we can say that they are in phase. So what is the meaning of in phase? If I draw a line to represent their relative position, so after some time, say t1, okay, I reached this point and V reached this point, but they are on the same line. There is no relative gap between them. Okay, so in the train example, I say, suppose there is another person C sitting next to A. Okay, so in that case we will say that the distance between A and C is 0. So they are having same phase. Okay, so this is called same phase, even though their values are different. If you see, whenever V is attaining the peak, at the same point I is also attaining the peak. When V is going to the lowest possible values, I is also going to the lowest possible values. When V is 0, I is 0. When V is 0, I is 0. So every time they are going to 0, they are going to 0 together. Every time they are going maximum, they are going to maximum together. Whenever they are going minimum, they are going minimum together. So this is why it is called in phase. Okay, so they are called in phase. So current in a resistor is in phase with voltage. Voltage is independent, voltage is applied externally, but current changes based on what is the equipment you are using. So when you are using say resistance, you will say that current is in phase with the voltage applied. Okay, so current phase is important, right? Now let's move on to the next part. Now you will see how the phase changes. We are now using a device called inductor. If you remember, we have used self-inductance, coil, okay, the mutual inductance for two coils. For a single coil we have used self-inductance. So basically this is the self-inductance, and the self-inductance of the coil is L. And the symbol of a single coil, this is only single coil, right? So whenever current is trying to increase in this coil will try to prevent it. This coil will try to prevent that increase of current through it, right? Because of the self-induction, because of the electromagnetic induction. There is a Faraday's law and Lenz's law. Lenz's law states that it tries to prohibit the cause of the change, right? So when the current is trying to increase in this coil, okay, there is a magnetic field developed. That magnetic field produces a current in that coil itself, and that current actually tries to stop the flow of current. Similarly, that is for the first half. Okay, now when the induced current is decreasing, voltage is decreasing, sorry, when the voltage is decreasing, okay, current the induced current will try to stop that as well. So you will say, okay, don't go down, stay as it is. So there will be an induced current as well, and that induced current will be again try to oppose the decrease. It will say, no, now don't decrease, increase. Okay, they are always fighting between each other. Now, so there is a relationship between these two things. Now there is no external resistance is connected. So how it is happening? So there is a change in current. So current in this circuit is not constant as usual. Current is changing, right? Now we know that the induced current and the voltage will try to cancel each other. What is the induced current? Just before that I solve in homework problem that induced voltage is minus L di by dt. This is the induced current, sorry, induced potential, induced EMF. Now what they will try to do, they will try to make this balance. So there is no external resistance is connected. So normally the voltage that we are applying, that should be equal to the induced voltage. This is the induced voltage, this is the induced voltage, and this is the applied voltage. So they will try to cancel each other and the resultant should be 0. Right? Now we can write this as di by dt. Okay, we have taken di dt on the left hand side and the negative sign will on the other side, so it will become positive now. So is equal to V by L. Right? From this equation you can write this as, so there is a step jump if you are wondering, L di dt or di dt is equal to V by L. Right? Or what is V by L? V is basically Vm sin theta. So we have used Vm sin theta and we have written that as Vm by L sin theta. Now this is given in terms of di dt. This is not current. To find current, what we have to do? We have to write it in like this. This is wrong. Di is equal to Vm by L sin theta dt. So next step, what you have to do? You have to integrate this. This is a constant, so constant does not get integrated. Only thing will be integrated is di and this sin omega t dt. So we can write this as I equals to, now what is the integration of sin omega t or sin x? Remember, what is the integration of, say, sin ax dx? If you remember, integration of sin ax dx is minus cos ax divided by a, right? You know that. So that same thing we have applied here, minus cos omega t divided by omega. Okay, so cos ax by a, we have done the integration and then we have rearranged it, right? Or we can write this term omega L as a new quantity XL. It is called inductive reactance. And if you see, the name has a very similarity with the term resistance, and in fact the unit of inductive reactance is same as that of the resistance, that is ohm. Okay, unit of inductive reactance is same as ohm. Now we can write this Vm by omega L as Im. Okay, so if you remember, in case of resistance, we obtained V is equal to Vm by R sin omega t, right? Now in case of inductor, we obtained I is equal to minus Vm by omega L cos omega t and we have written this as Vm by XL cos omega t, right? This was for resistance. Now this one we are calling as Im. Okay, this is the maximum value of current now. Now what is cos omega t? Cos omega t basically is nothing but sin pi by 2 minus omega t. But here there was a minus sign, right? So minus cos omega t will be, so we have taken the minus sign. You can multiply both sides as minus, and we can take the minus side inside because it is a sign. So it will become omega t minus pi by 2. Okay, for sine it is possible to take the negative sign inside, and you can also verify in terms of all sin tan cos, and you can say that this is the value of the angle. So that is what is done here. Okay, so Vm by omega L is now Im, and minus cos omega t is now sin omega t minus pi by 2. So if you compare in this case, okay, voltage was sin omega t, current was also sin omega t. This was for resistance, right? For in case of resistance, voltage and current both are sin omega t. But in case of inductor, it is no longer sin omega t, but it is a sin omega t minus pi by 2. So this is the phase difference. This is called the phase difference, right? Now what is the sign of this? This is a negative sign. So negative sign means it is lagging behind. So if voltage is here, suppose the voltage is at this point, okay, at some point, then current is not only less, but also it is behind. Behind means in this side is behind. As we are moving, we are rotating, we are assuming that this is rotating in this side, right? It is rotating, this like an arrow rotating in this side. So arrow rotating in this side means whatever angle is made by this is positive, and if it is negative, that means it will be in the behind state, and that angle will also be pi by 2. Okay, that angle is pi by 2 because this is the phase difference. So angle between them is fixed. This is pi by 2 and they are rotating like this. So they are always rotating, they are having a fixed difference. So this is the engine, this is the car behind the behind. So this is like the person sitting in B, okay, and this is the engine and this is rotating like this. And if you see, when voltage was 0, current was negative maximum, at the negative maximum point, okay, or minimum point, you can say that. When voltage is maximum, okay, current is 0. When voltage is 0, current is maximum. So this is happening again and again. So there is a distinct phase difference when you are considering inductor, and we say that current lags the voltage by pi by 2. So leading, lagging, same phase or in phase. Okay, here it is lagging. Okay, so current is lagging by a phase pi by 2. Now what is the power? The third important point for any either resistor or inductor, or later on we will see capacitor, how much power it will consume if we fit it in the circuit. Okay, so we know that power is VIT, vitamin, okay, and we can write this as Im sin omega t minus pi by 2, I have already explained, and Vm as Vm sin omega t, right? Now we can write this as this sin omega t, we can write this as negative cos omega t. So if we put this value, we will get cos omega t sin omega t, okay, and there is a negative sign. Or we can write this as, so what is sin 2 theta? If you remember the formula of sin 2 theta, it is 2 sin theta cos theta, right? So the same thing we have done here, it was sin theta cos theta. So we have to use divided by 2 and write this as sin 2 omega t, right? Now what is average power? I told you in our previous plot that average of sin theta is 0. So in this case, this is constant, so this will be out of the average part, and this is the sin theta term. So average of sin theta is 0. So we have written this, the average power consumed by an only inductor, purely inductive circuit, is 0. So the power consumed in a pure inductive circuit is 0, right? So power consumed in a pure inductive circuit is 0. Pure inductive means nothing else is connected, only inductor is connected, that is called pure inductive circuit. Okay, now one question: which of the following represents the variation of inductive reactance XL with the frequency of the voltage source V? So what is the inductive reactance? Inductive reactance is XL is equal to omega L. Also we know that omega is equal to 2 pi frequency. So XL is equals to 2 pi nu L. So we can see that XL is directly proportional to nu, no square, nothing, not inversely proportional, linear proportionality. Linear proportionality means obviously it will change as a straight line. So correct answer is option A. Correct answer is option A. No need to look into anything else. As long as you know the relationship, you just need to draw the graph. This is also from your previous year questions. Okay. Now we will look into capacitor. So capacitor we have studied already with DC. Okay, what happens when you connect a capacitor with a DC source? The capacitor will, the plates of the capacitor will start charging. Okay, and one end of the capacitor will become positive, another end will become negative till it reaches the potential of the battery, and then it will stop. Okay, so initially the capacitor will charge till it reaches the maximum value, that the charge that it can store. Once that charge is reached, then the capacitor will not charge anymore, it will hold that charge. So we have solved some problems like after a fully charged capacitor, capacitor is connected to the battery for some time, then we inserted a dielectric slab. What will happen? We remove the dielectric slab. What will happen? We charge it with the battery, then remove the capacitor, then insert a dielectric slab. What will happen? So these are the different cases where we have dealt with DC. Now what will happen with AC? So when the current, the voltage is increasing, when the voltage is increasing, the capacitor will start charging itself, right? In this case, so suppose when the charge is increasing, so voltage is increasing, then this side will be positive, okay, this side will be negative. Now when the voltage is decreasing, okay, this side will now be negative, this side will be positive. So initially the capacitor will charge, then when the current starts decreasing, initially the capacitor will discharge, then again it will charge in the opposite direction, right? So the charge, the polarity of the capacitor will keep on changing with each cycle. This is called one cycle. So with each cycle, each half cycle actually, it will keep on changing. So how we can find the expression for current? Okay, so capacitor, what we know, for a capacitor we know that Q is equal to CV. So how much charge it is storing at any point of time, at any instant. Suppose the charge stored in the capacitor is Q. Okay, then from the relationship of the capacitor we know that Q is equal to CV, or V is equal to Vm sin omega t, that also we know, right? And what is current? Current is nothing but the time rate of charge. So time rate of flowing charge, so we can write current as dq by dt. Now what is dq by dt? CVm is constant, so it will be out of the integration, differentiation. Omega is also constant, so remember that differentiation of ddx of sin ax, ddx of sin ax, what is that? It is equals to a cos ax, right? Cos a cos ax, right? So same thing we have done here also. Omega is common, omega cos omega t, right? Or I is equal to Vm by 1 by omega c, right? Now what we have done, we are trying to write it is in terms of, so remember that I is equal to Vm by R, right? Sin omega t, that was for resistance. So our target is to find this R for capacitance as well. So what we can do, that it was Vm omega c, right? So what we can do is, we can write this as Vm divided by 1 by omega c, right? This 1 by omega c, if this goes up, it will become the same as that. So that we have done the same thing here. Now here this xc is called 1 by omega c. So now we are naming this term 1 by omega c as xc, and it is called capacitive reactance. Okay, capacitive reactance. Same thing, it also has the unit as ohm. Okay, we will see that in later part when we are calculating the impedance. So xc is the capacitive reactance. Also here Im is basically Vm by 1 by omega c, and we can write current as Im sin omega t plus pi by 2. So in case of minus cos omega t, we have written it as sin omega t minus pi by 2. In case of plus omega t, we can write this as sin omega t plus pi by 2. Okay, so this is basically in second quadrant, which is positive, so we can write, for sin is positive, so we have written it like this, right? Now we can write current as Im sin omega t plus pi by 2. Also we know that voltage is Vm cos, sorry, not cos, my mistake, sin omega t only. Okay, sin omega t. So now we can see that these two have a phase difference again, pi by 2, but in this case what we can say is that if you see, this is plus pi by 2, so this is ahead in time. So when this is reaching pi by 2, okay, the current is already ahead of voltage. Okay, so we can say that here current leads the voltage by pi by 2. So when the voltage is maximum, current is 0. When the voltage when the current is maximum, voltage is 0. When voltage is maximum, current is 0. So there is a pi by 2 phase difference, but initially current is ahead of the voltage. Okay, so this why we say current leads the voltage, right? Now let's look into the power part. So power is again the same way. We can write this as Im sin omega t plus pi by 2 into Vm sin omega t. So you know the drill. Okay, so similarly we will write this like this, and then again Vm Im sin omega t, or average power will again be 0. So power in a pure capacitive circuit is also 0. So average power in a pure capacitive circuit short form is CKT, is 0. If you have any doubt, you can mention that in the comment. Okay, we have almost reached. So I have reached the end of the lecture today. So you can note down the homework and solve it. Okay, and mention the answer of the homework in the comment below, and pause the video if you want. You can download the PDF from the comment below. Whatever way is suitable for you, you can pause the video, solve it, mention the answer in the comment below. This is the homework number 2. Okay, another important question. All the homeworks that I give are very important questions, very important type questions, so don't miss out on homework as well. So now solve this question, mention the answer in the comment below, and if you have liked our videos, you can find all the playlist of all the liked videos. All the videos that I have done in this KCET series is available in KCET 2025 physics playlist. You can visit this playlist, you can watch all the videos available in this playlist, chapter wise, concept wise, topic wise, everything is there, including KPL previous question paper discussions. So everything is available in this playlist. You can go and download, or you can save the videos, watch it at any point of time you want, and you can bookmark this page as well. So I will hope that you are watching all the videos, and if you have not yet joined our WhatsApp group, don't forget to join our WhatsApp group. And if you have not yet joined our channel, if you have not liked our channel, don't forget to like, share and subscribe to our channel. Share it with your friends. Whoever is preparing for KCET 2025, they will all find these videos very useful. So I will back with the AC part 2 in our tomorrow's lecture. So till then, tata, bye bye.